We are SSoA students from Climate Action, a student-led action group from Sheffield School of Architecture campaigning for a greater emphasis on sustainability in architecture education. We are delighted to be joined by SAS Alumni today, and as SAS students, we are encouraged to develop a critical stance in relation to theories of sustainable architecture. So today the lecture will be in two parts. The first group will present their work, followed by a Q&A round of just about 10 minutes. And then the second group will present their work, and then we'll have an overall Q&A round. Before we begin the lecture, we just have a few ground rules, housekeeping rules. If everyone could mute their microphones and turn off their video, that would be great. And there will be a time at the end of the session to ask any questions you may have. So that will be done through the chat box function. And finally, before we begin, we will be recording the session for you to watch back in your own time for anyone who has missed it.
So today's afternoon session is going to be all about sustainability in architecture. And as designer, it's a responsibility to create a very habitable environment for the people to live in. And it's not just for the present, but also for the future generations to come. So, sustainable architecture is not just a term which people use for a building to be green or for a green building. It is much more than that. There's so many other factors which are considered for a built environment or a building to be sustainable or energy efficient. So those factors include construction materials which are used, the building technique and design principles, the climate of the place, and the threats, the possible threats the place or the building faces, and so much more than that. So today's projects will be focusing more on how building retrofits are considered to be more sustainable and economically efficient. And there's no one better than our SAS alumni to share their design methods and their ideas through their projects, and towards a clean and green environment.
Okay, so let's start the session. So the first group is presenting the Beaufort Project, which is located in Sheffield, UK, owned and managed by South Yorkshire Housing Association, and is part of our Livewell project of service across the region. Beaufort Projects supports adults with long-term mental health needs to live independently in the security and privacy of their own home. So now I will hand over the session to the group, and one of the group members can share their screen to present their work.
So hello everyone. Our team is doing project Beaufort project, and we have 4 teammates. And I'm Wendy So, and I will report our work here. So first, we want to achieve sustainability by 7 steps. And so first, we did a background study of our site, and I will go through this part very quickly. So here is a site, and it's located in Sheffield, and the climate condition was quite good, and with mild summer and and with low wind speed here. And here is we did a study about climate prediction in the future, and the general temperature had a tendency to increase by 3 to 6 degrees here. So the climate change would be a big concern of our project. So here we did some analysis about our site, so to help us better understand our location. So here is a ventilation condition. So here is a wind condition of our project, and here is a solar radiation, and by this we can say that there are no high-rise building around our site, so that the solar energy could be used in our project. And here is so because our project is very special, and it's for the special people who with long-term mental health needs. So we did some background study about the mental health problems, and we can see that there are 3 special needs for the special people. The first is safety and socializing, and also the comfort needs. And with our to better understand our residents, we did a daily routine analysis of our residents, so that we can better understand their daily activities in this way. And here is a questionnaire did by MSc students, so that we analyze the questionnaire and summarize some problems in our project, such as the office is quite dark and more the noise from the students nearby are quite need to be solved. And also because we also learned that the decoration style maybe affect their health. So we also did a color study about in this term. And here is a solar radiation simulation of our project. And we can see that the north facade also can receive enough solar energy in this way. And our house has a quite high energy consumption in originally, so this could be this have to be changed in our project. And here is the daylight factor and the illuminance. We can see that our building, the inside space of our building was quite dark. Yeah, so here is the function analysis. Because the house was quite was built for several years, and the function was quite simple, and the circulation was quite complicated, and this is not suitable for people with mental health problems. And we also analyze the structure because we plan to change this a little bit. And here is a summary of our building, so that we can see that there are several problems that the building is divided into two separated buildings, so that people cannot go from one building to another directly, and also the bad insulation of the walls and windows, and also there is no shading device of windows, so that it would be terrible. And we also there is another section of our building, and these problems could be changed in our project. So here is our SWOT, as I said before. So here is we did some case studies about the buildings for mental health for mental health people, and also some passive house studies. We select BRAIN as a mentor as a benchmark of our project because it's quite because it's combined of energy, health, and some other factors in this standards. And our vision, we have 6 visions in our project. We want to achieve thermal comfort and improve indoor daylight quality, and also increase variety of communal spaces, because the people are encouraged to communicate more with others. And also we want to achieve low energy consumption targets, and also ensure ventilation with safety. Finally, we want to improve water efficiency. So here goes our overall solutions of our project. So first, we change some we did some visual changes of our project, as we can see that we add some steps and rows in our site, so to make our buildings more accessible. And also for our layout, we did some very key point changes. For basement, we added a storage room to store some medical machines and some other things. And also for ground floor, we added a glass connection box to make sure that people can go from one building to another very conveniently. And also for first floor, we added some. We also added some communal spaces, and we demolished stairs of building A of the top building, and also added a lift instead. And we also increased the number of the self-contained rooms because of the total increase number of the residents. So here goes a section. We can see that our building is located on slope, so there may be some high difference between the two sides of our building. So this may be an opportunity to our project. And here is our potential solutions to our building. So we want to add some insulation to of our building envelope, and also add a light bill in the middle of our our building to bring natural ventilation. And also we want to introduce the MVHR system to encourage natural ventilation in our building, and also a rainwater harvesting system to better reuse the water. And we also add some PVT panel on the roof, so to use the solar to better use the solar radiation. So here I will talk about our solutions in detail. So first is about insulation. So we added the insulation of our building, and we also select to use double facade in our building. We selected timber as the main material of the double facade, and because due to the climate prediction of Sheffield, the general humidity would increase by 2050. So we also just changed the shape of the double facade a little bit to better prevent moisture in this project. And we also select new window types. We changed the original double glazing to triple glazing to better prevent heat, and also to improve air tightness. And we also add a window box outside building, and there are some small holes in this box so that people can see each other from their own home to greet with each other or something, so that people can communicate with others. And we also introduce a adjustable timber shading system. By applying this system, people can adjust the angle of the shading by themselves, depending on their preferences. And this is a detailing of this shading system. And for space, as I said before, we just added some communal spaces such as middle connecting box, and we also demolished the stairs because there are 2 stairs in our building, and we think lifts is more convenient for those people with special needs. And we also added art studio in the north building, because we learned that some artworks may be helpful for their mental problems. And here is some sketch about the public spaces. So for structure, because we added some big communal spaces, so we just changed the structure a little bit. We just demolished some load-bearing wall, and instead we added some columns and beams to bear loads. And regarding the renewable energy, first we consider use in this project was solar energy, because the orientation of this project was quite good, and there are no shading around our site. So we add some PV panel on the top of our roof, and also added a ground source heat pump, so that we can see that the location of the system was under our garden. And also we want to introduce the MVHR system to encourage natural ventilation, and also applying rainwater harvesting system and green water recycling system to better reuse the water. And for thermal fields, we just prioritize the self-contained spaces, because the residents would spend most of their time in their own rooms, and followed by this, we pay attention to some assistant spaces such as the shared kitchen, offices, and the toilets. As we can see that we add some mechanical ventilation and also increase the insulation to improve the indoor thermal sensation. And we also designed an artificial lighting system in our project. As well as thermal fields, we just prioritize some important spaces in this building, such as the toilets, the kitchen, and these assistance spaces, to reduce the danger of using these spaces. And in some special spaces, such as base room, we just use automatic lighting system so that people don't need to operate by themselves. This is quite convenient for the people with mental problems. And for same space, we just select different type of the lighting system so that people can select depending on their preferences. And also we consider about future design because the total number of the residents in this project was changeable. So if the total number are increasing in the future, that's we design some movable walls in this building so that people can change the layout of the building by themselves to adjust the change of the number. And we also plan to grow some plants in the window box because of the global warming and the temperature could increase in the future, so that these plants could prevent heat very well. Because we select timber as the main building materials in our building, so we did a study about the timber suppliers around our site to reduce the transportation costs. And there is a timber life cycle in our building. So besides the sustainable material, we also want to reuse the original bricks in our building. Because we just demolished some wall, and we want to crush the bricks and use it as rows in our garden. And because our project was funded by a company, and here we gave a checklist of the total cost of our project. So here are some visual renderings about our building. Here is a south facade and also here is a garden and the connecting box. We after applying our solutions, we recalculated our energy consumption, and it's now reduced to 213, and it has met the standard of architecture 2030. And the daylight factor has improved a lot, especially the south side, as well as Illuminance. Considering the thermal sensation, we calculate PMV value both in CBE website and IES software. So this is a result of CBE website. We can see that the PMV value in our building was always between -0.5 to 0.5. Which means residents could feel comfortable inside our building. And the result of IES was quite similar to the CBE web page. And we also did the BREEAM rating, and our project was scored with outstanding. Besides this, we also want to achieve the Passivhaus standard in our project. We did a lot of things, especially we select the window type and the doors type to improve the airtightness of our project. And we also try our best to reduce the thermal bridges of the building envelope, especially at the corner of the wall. And we simulated our building in PHP software, and our building finally achieved met the standard of Passivhaus, because our house was a retrofit project, and the standard the Passivhaus standard for this was 25, and our final score was 19.8. So here is our project. Thank you very much.
Thank you, Minji. That was an interesting project. It was fantastic insight into the breadth of the project you undertook and the process. So we are now moving to the Q&A part session. And if you have any questions, please start typing in the chat bar below. And we will keep this round for just 10 minutes. So if anyone has any questions, you can put it on the chat box. So I'll start with the first question first. So yeah, so we have a question from Gary.
What would you get advice to?
Yeah. So what should be your best advice to aspirants in pursuing to do sustainable designs based on your research study? And what are the most important ideas and topics we would always remember to guide us so that we could exactly achieve those research studies you had mentioned in your lecture?
So that I think the most important ideas in our project was the needs of the mental health problems, so that we have to change sustainability based on their own needs, so that you can see that what we added some we changed the window type and also the doors type to on the one hand it can ensure their security, and on the other hand it could improve the airtightness of the total building. And on the other side, we pay much attention to the indoor air quality, such as the ventilation and the thermal comfort. I think this is really important in a sustainable project.
That's great. I hope you and Gary got the answers. So I also have one question. I was interested to know that you guys have actually done a questionnaire thing before starting the project. So I was interested to know if it was possible for you guys to do post-occupancy evaluations, and would it have been more successful if you got the data, like how were you able to achieve?
Yeah, I'm sorry, because our questionnaire was given by the MR students. We didn't do the questionnaire by ourselves because, the project is quite special, and we didn't have we didn't be able to access the building. So we just summarized some important questions by the previous studies.
Okay.
Sorry for that.
Great. So we have another question by Paula. She asked, I think you used DF for lighting. Is daylight factor a good and relevant metric for measuring daylight in indoor spaces?
Yeah, basically for daylight in indoor spaces, we use just daylight factor and illuminance. I think both can show the indoor light quality, because the evaluation, the simulation result was not quite good. The original one was quite dark, and we improved it a lot. You can see that the illuminance was about the whole year. We can see that from month to month, and the daylight factor, we can see a general condition of a whole year. So because from our simulation results, we found that the south side light condition was quite good, so we didn't change it too much, but we improved the light condition on north side a lot.
That's great. So I hope you answered the question of Paula. And so yeah, do we have any other questions, or we can move to our second presentation? Great. So Aishwarya, I hand it over to you.
Okay, so now the second group will be presenting the Main Road Eco Village Social Housing Development, which is also owned and managed by South Yorkshire Housing Association. And the project sits on a 14,000 square meter greenfield site located in Unstone, Northeast Derbyshire, and includes 37 new built housing dwellings, a communal building, a commercial spaces. The 1 to 3 bedroom terraced and detached houses have been designed based on Passivhaus standards and incorporate sustainable design principles and renewable and low carbon technologies. The main aim of this project is to create a passively designed housing community which is responsive to immediate context, enhancing the user's well-being and promoting sustainable lifestyle. Now I shall hand it over to the second group to speak more about the project. So who wants to share, Shahab or Vishnu, either of you can start.
Yeah, I hope you can see my screen. Yeah.
Yes,
Yes, we can.
Okay. So hello everyone. I'm Shahab, and I'll be joined by my friend Vishnu in presenting the Main Road Residential Eco Village. I'm really happy to join this session, and I hope that we can transfer what we've learned throughout the project to all the people who are present. Just to point out, we've summarized the presentation so we could just present the relevant parts. So we've omitted some parts from our project which we thought were not necessary for this presentation. Um, as Celine pointed out, every design in sustainable in the SAS studio starts with the 7 steps to sustainability, which starts with the research and looking at the background of the project, then going into the vision and objectives, what we are aiming to achieve. And then based on that, we go into the solutions and the design and the strategies. And finally, we validate those strategies with physical models or simulations. And we end all of that with a feedback from the real project if it is built and from the users in order to incorporate it into future projects. So our project, as my colleague pointed out, is located in Unstone, which is 20 minutes from Sheffield. The site indicated with red here is located next to a main road with a river Drone passing by to the east. It's a very sparsely dense site, so there are not that many buildings around it, and there are no trees in the site, and it's also located next to a junior school. We did some site analysis looking at the shading and the wind in the site. The main direction of the wind is from the south to the north, and also a secondary direction from the southwest to the northeast. And the site also has 2 slopes, one from the south to the north and another one from the west to the east with a drop of 12 meters. These 2 points helped us with zoning the site, as you can see on the right. And we divided the site into 2 parts of 2 segments, and with a main axis passing through diagonally from the southwest to the northeast. And with the housing projects on the west and on the east side, and also some public spaces next to the main road. These are some views of the site. You can see the main road, the school, and also the view of the site here. The main vision of the project was to achieve a passively designed social housing community responsive to the context, which also enhanced the well-being of the users and also promoted sustainable lifestyle. Because the project is because it's an empty site, our objectives are divided into 2 levels, one at master plan level and one at the cluster and unit level. All in all, we were trying to achieve an energy efficient site, which would enhance community engagement and also achieve sustainable goals such as water harvesting and waste management. And we were also after good air quality, lighting, and thermal comfort inside the spaces, as well as good quality of spaces and good design. I'll hand it over to Vishnu.
Hi. Before kind of starting the designing project, we went through a series of analysis about the kind of user group we're going to have and the community activities that is going to happen on site. So we found out that we'll have families, couples and single parents and elderly people and single occupants also, and then kind of charted down all the activity of all the user group. Next. And then we kind of did activity analysis of all the users from the day to night to understand the occupancy pattern. Going to the master plan, we initially started with really vague ideas of how we can arrange the units around the site, because it was a slopy site. So we always had to take care of the diagonal valley that we have in the site. So we had gone with organic clusters, courtyards, straight rows and staggered patterns and earth sheltered buildings. Next. Then we had kind of shortlisted 3 options. First one being a very geometric, first one being a very north-south oriented geometric arrangement, but looks inorganic. Second one being straight lines. Third one being a combination of both, with organic lines on one side and inorganic clusters on the other side. And then we have started detailing out the third one because it actually looked very interesting, and how organic and inorganic arrangements form the community space. So we had started detailing out, and we did an analysis of what advantages and disadvantages we have with both the kind of arrangements. So that was the final layout. So on one side of the diagonal, so the diagonal access became the open community spaces with the community center, and also the water body that you see in the center is actually following all the slope of the site, so that we are not doing any mechanical pumping of water to collect the water. And on the left, you see the rows of houses orienting south-north. They are actually 1-bedroom and 2-bedroom units arranged one above the other. On the right, you see is cluster of 3-bedroom community kind of arrangement. That's the overall view of the site, of how we've kind of made parking all around the site and not in between the residential units, still having emergency access to each and every unit, and then orienting all of them to south and north so that we take advantage of the sunlight to generate electricity by solar panels. Yeah. Then we, to understand how much area of the site we are using, and for various activities like, wastewater management and rainwater harvesting, woodlands that we are proposing on site. So we did an area allotment. So we understand that. So that's again a detail of all the layout. Next, all the spaces in the layout. So for rainwater management, what we have done is it was 100% possible to collect all the water from the roof sheds. So we are collecting all the water from the roof of the building and putting them back into the earth by groundwater recharge units. And the centrally located swale that you see is actually following the slope of the site. That's collecting all the water from the site. So in that way, we are trying to collect all the 100% water that we are going to get on site and pump it back to the earth, pump it back to the ground by using bioswales and very dry landscape in some areas which can retain water. So you can see some detailed sections of how the swale is proposed and how the woodlands are proposed around the water body to avoid evaporation. That's a detail of groundwater. On the right, you see, and then in the lower section, you see the allotment areas in between the units and how the water is again collected into the allotment areas. Yeah, that's the section through the swale in the bottom. On the top, you see the section in between of how we have avoided noise from the parking areas into the buildings by having earth berms, mounds in between the parking and the buildings, and divided it by woodlands. Next. That's the view from the community center, overlooking the bioswales and the community of the units in group. Waste management and allotments, you see in the red in between the units is allotted land for vegetation and farming for the people, so that we kind of inculcate people to have a grow their own vegetables and be self-independent. On the top that is marked, you see, is actually land allotted for waste management. So all the waste is taken care and segregated and composted, so that we create manure for our own site and use that in the landscape around. Biodiversity in terms of the site itself is rich in the surroundings, so we have kind of taken up local species of flowers and woodland trees and grasses and flowering trees, proposing them in the site, so that it grows healthily and we have a green seasonal site all along the year. Next. That's the view of allotment and the row housing, how every building has an allotted land in front of it, a piece of land, so that people actually use it to grow their own veggies and fruits, so that, and also develop a sense of community in between the people. Coming to the side section, this is the section through all the row housing. You see balconies overlooking into each other, rainwater harvesting system following the slope, peripheral parking and pedestrian pathways in between, and how we've kind of retained sustainably the earth, and by cutting from the site and filling on the same site, we have kind of gone ahead with the shape of the site without disturbing a lot of geography of the site. We've just gone ahead with taking the shape of the existing site. What you see in the center is an earth shelter building, which is a community center overlooking the valley. So it kind of, there is no structure when you're entering on the site from the top. You don't actually see it. There is no structure. What you see is only residences, but you actually have a community space which is into the ground with skylighting and all of that. This is a cross section in the other direction, where you see how we have placed the site at this particular location, so that the house behind actually receives sun all along the year, and also that helps in efficient functioning of the solar panels that we are using. So the idea of going ahead with 3 rows was because we had to have this for 100% functioning of solar panels and to keep our spaces warm throughout the year. Next. This is the cross section through the community clusters. Very straightforward, same, we followed the slope and swale. Go ahead. A zoom in section of how we're trying to inculcate a sense of community in between the people by having overlooking terraces into the allotment areas, so that becomes more social, and the sense of community is kind of there because the architecture is creating a sense of community here. Go ahead. That's the detail of the section of the community center, how we're doing a naturally lit earth-bomb building. Go ahead. Zoom in of how we've arranged the buildings for maximum utilization of sun and keep the spaces warm. Windows and cross ventilation in space. So this is unit 1 that we have with basically we are trying to play around with the form so that we could arrange everything around a cluster. It was all about scooping the spaces, have terraces overlooking into each other, and how we have verandas and inside and outside space, also taking care of ventilation and natural light in all the spaces. So this is a 3-bed, that was a 3-bedroom that was a 3-bedroom unit. This is unit 2, which has a 1-bedroom unit in the ground floor and 2-bedroom unit on the 1st and 2nd floor. So you see an independent staircase going up. So we have 3 levels of terraces looking into each other and kind of giving independence on the upper, independent privacy on the upper levels also, and also the lower levels have independent courtyard in the front and the back. Go ahead. So that's unit 1 with 1 bedroom in the bottom, two bedroom on the top. stacked upon each other with a separate staircase and entrance. Go ahead. That's this the second unit, 2-bedroom unit on the top with two terraces and sometimes 3 terraces attached to each other. What you see is a very simple, straightforward unit, but the real interest of the project is how we have done well ventilated, well lit, very simple planning, but amazingly functioning spaces. In moving out into spaces and overlooking into terraces. Go ahead.
Moving on into the details of the building. All of the buildings use a balloon frame system instead of the traditional system where the floor joists sit on the wall studs. In this system, the wall studs are continuous past the wall joists, and the reason that we've used this framing system is we wanted to achieve air tightness throughout the building, and using this framing system makes the air tightness detailing much easier. The entire building uses a timber frame structure with timber trusses for the roof and clay tile roofs. So looking at the details of the exterior walls, we have the 140 millimeter timber wall studs, which are filled with 140 millimeters of sheep wall insulation in between and an extra layer of insulation on top in order to achieve thermal continuity. And the most important part for the thermal continuity and the air tightness is the detailing of the joints. So here, if you look at the, the foundation, it's a very simple foundation. It uses EPS insulation on the bottom and also edge EPS insulation, which in addition to providing thermal insulation, acts as the shuttering for the flat slab, which is used for the foundation. So here, the floor slab and the foundation are combined, and the reason that it is flat is because it helps with it's easier to construct because these are small buildings and the workers which are used for these types of construction are not that familiar, are not experts in very complex foundations. And also using these ESO quick modules helps with the thermal continuity and attaching these insulation parts to the insulation of the wall. And here you can also see that balloon framing system where the floor joists are not disrupting the wall studs and helps with the air tightness. For the air tightness, where we've used OSB boards instead of membranes, and the reason for that is the use of membranes is again, it's harder to use those. It's harder to achieve the air tightness. It's hard in detailing. You have to be very careful with the creasing and not creating any holes. But with OSB, it's much easier to achieve that. And these OSB boards are also covered the space between the different panels is covered with adhesive tape, which helps with the air tightness. And behind each floor joist, there's additional taping, which is connected to those OSB boards, which creates a continuous layer of airtight panel. And the foundation itself is airtight by itself. And the building also uses underfloor heating. And the second connection, which is important, is the roof to the exterior walls. Here again, we have rafters which are connected to the wall studs with wall plates, with timber wall plates, and with 300 millimeter insulation in between, and an additional 120 millimeter insulation on top. Again, we have continuous insulation between the wall and the roof, which helps with that thermal continuity. And again, we've used OSB boards, adhesive tape in order to achieve the air tightness between the walls and the roof. This is an overall section of the building, and it incorporates all of those details that I explained. The reason that this was important, the air tightness and the thermal continuity, was our goal was to achieve Passivhaus. And in order to achieve Passivhaus, you have to follow some steps. One of those is air tightness, the other one is thermal insulation and zero thermal bridging. And the third and fourth strategies are using passive measures and also adequate ventilation strategies. Passivhaus itself is a standard, it's voluntary, it's not compulsory, but all in all, what it does is it uses a small amount of energy to save a large amount of energy. So buildings which are Passivhaus use substantially less energy compared to conventional buildings. And the aim in these buildings is to achieve overall primary energy demand of lower than 120 kilowatt hours per square meter per year, and an overall heating or cooling demand of 15 kilowatt hours per square meter per year. Again, these are the strategies used for the zero thermal bridges and the strategies used for the air tightness of the building. If you have any questions, I can go through them at the end of the presentation. The second strategy that all Passivhaus buildings use is MVHR system, so it's mechanical ventilation with heat recovery. Because these buildings are very airtight, in order to provide fresh air into the building, you have to use an MVA mechanical system. But because we want to reduce the energy use of the building, it's coupled with a heating recovery system. So what it does is it collects stale air from the kitchen, from the bathroom, and so on, passes it through a mechanical ventilation system, which transfers that heat into the incoming air in order to reduce energy demand of the building. And this is used for the ground floor unit and also the first and second floor units. And in addition to all of those, we've also used renewable and low carbon technologies, which includes a ground source heat pump for heating the water used in the building for sanitary water and also for heating the building. And the energy required for this heat pump is provided by the PV panels. So there's no need for any electricity or gas from the city. But in order to back up the systems, gas and electricity are provided if any of these systems stop working or something goes wrong. Vishnu went through these design strategies. I won't go through them again. Some visuals of the buildings, interior visuals. And the final part is the validation. So because these buildings are not built, the validation is based on simulations in Revit and also IESVE. The first on site level, we have solar radiation evaluation, and because of the staggering of the units and the slope of the roof, we don't have any overshadowing issues with any of the buildings. Also, we've looked at wind flow. There are no issues with that, and the only problem is with the south to north winds, which is resolved with the use of vegetation and trees. And also, we looked at the incident solar radiation on the buildings in order to locate the solar panels, and the best place to locate them is on the roof because they receive the most amount of solar radiation throughout the year and different in summer, winter, spring, and autumn in different seasons. And then we've looked at the interior illuminance using Revit and also IESVE, and as I also pointed out, IESVE is better because it uses climate-based daylight modeling. And based on these, we see that all the rooms achieve sufficient amount of daylight. And we've also looked at thermal comfort and overheating issues. The building manages to resolve any overheating issues as well. The overall energy use of the building is 115, which is lower than the Passivhaus standard requirements. And we've also looked at the energy use, the carbon emissions, and the running costs of the building using Green Building Studio, and the cost for the water usage and the panels, PV panels used. The overheating risk analysis of the building is done with Good Homes Alliance tool, and that points out that the building has low overheating risk. For Passivhaus, we've looked at different options, different massing, and different forms for the building. The the main strategies in order to achieve passive house are a very compact design. That's one of the reasons that we have a very compact design. Large amounts of south glazing, very low amounts of north glazing, no glazing on the east and west as much as possible, and using shading, vertical or horizontal shading, and also movable shading in order to achieve that. I won't go through the calculations. These are calculations which are done in the passive house planning package to see how much the energy use of the building is, how much the treated floor area is, and the thermal envelope, and also the glazing area. And these are the results. In all of the units, we have managed to achieve the standard requirements. And in the end, we looked at the future climate in 2050. The North UK, England will in 2050 will be much similar to London. So going through that again and looking at what happens, the heating demand of the building reduces, but the frequency of overheating increases. And in order to resolve that, we have to use ventilation and also different shading mechanisms. Thank you very much.
Thank you so much, Shahab and Vishnu, for presenting. This has been really, really informative and interesting. And now the platform is open for the audience for questions. So here, Gary is asking, based on your studies, are there any relationship or correlation in between the energy being used in the building and the existing thermal heat of these buildings? And what is the best advice in reducing the thermal heat of the building?
Yeah, if I go back to the presentation, give me 1 second, sorry. So in order to look at what happens in the building, if you use design pH, which is a plugin for the software that we use, it helps with the heat loss and heat gains in the building. The main thing is, if you want to reduce the energy demand of the building, you have to reduce the heat loss and also reduce the heat gains. And in order to achieve that, as I said, in order to reduce the heat loss, you have to reduce the glazing ratio on the north, east, and west sides, but increase the glazing ratio on the south in order to increase the heat gains. But this is a balance. If you increase it too much, you have too much heat gain. But if you don't have enough glazing, you won't have enough heat gain. So you have to balance the amount of glazing ratio. And in order to do that, you have to use software such as design pH, and also passive measures such as orientation, shading, and so on, and the roof slope, and so on.
Hope that answers Gary's question. There's another one by Jamil. What participatory methods did you use to engage them in the design process to help them appreciate or understand them better in terms of sustainability and design?
So we had regular meetings with SIA. First of all, they presented us with their goals and what their overall company view is about sustainability and so on. And based on that, we did our design, and then we had regular meetings with them, presenting our results and also our simulations, and then getting their feedback on what they want to achieve and how we can achieve that in a sustainable manner. I don't know if Vishnu has something to add.
Just a small example of how their suggestions and their kind of changed the design. Initially, we had like a single staircase block which was being shared by 2 units on the upper levels, but generally the issue in these kind of housing is who is going to maintain that staircase block. So there you are again inviting a third party to who's going to maintain the block. So that's why they said that no, we're going to go with every unit will have their own independent staircase, but then they have their own responsibility to maintain their staircase. So that kind of helped us in going ahead with practical reasons of buildings not being maintained if the staircase and the common amenities are shared. And secondary was with the landscape. Initially, when we had proposed a landscape, they had a lot of issues with how delicate and how elaborate your landscape is, because it's very difficult to maintain. And so then we increased our percentage of woodlands, and we did very small amounts of lawns and spaces which require maintenance. So in that way, we had a constant communication with them, and they were giving us design suggestions of what practically is possible and what should be done. So that, I would say, was an interesting thing.
And
Going back to the first question that Gary had asked about a small advice, I would say is design is definitely a major part of it, but what is the most important thing is the research on how you base your design and the validation of how you support your design with the validation. It can be anything. So it's really about not taking all the 10 things onto your plate. Just take 2 of them as your design objectives and do a thorough research of the two and give a thorough validation of why you're doing this particular design for the lighting or ventilation or any one topic that you select. So that, I would say, is validation is the key for anything in sustainability, that because you have to prove it in numbers.
Okay, thank you so much. Another question by Dilek. In what extent defining the user profiles was helpful in your overall design decisions? And what was the intention to choose underflooring heating, especially for a passive house design?
And the reason we use underfloor heating was for the energy demand. So because we're using ground source heat pump, it's better coupled with underfloor heating. And the user profile helped us with the design of the different types of units. So we have detached houses, which have a villa feel to them, which are mostly one levels. So it's not like multiple levels. So it's better for elderly. And also another reason that we have 2 units stacked on top of each other is that the ground floor can be used for the elderly, which might prefer a building without staircases. And the second level is more suited towards single parents or families. So that helped us.
I think it did. Yes. There you go. And the last question, did you work with a landscape architect to design for ecological sustainability?
No, we did not have the.
As I said, that it's very important to understand what you take as the aim and objective of the project. And we had a larger master plan strategy of how we're going to go ahead with the landscape and woodlands and how we're going to allot the space on the ground. But no, it would have been really amazing to actually, work only for the landscape of the project, but that would have just become an independent project in itself because the site is big. So I would recommend, if anybody is interested, we would be more than happy to kind of give away our project and get the landscape designed.
Okay, thank you. Any more questions? Yes, Anushka.
Yeah, I have a question. So basically, while studying the projects, while doing the project, you had 3 typologies. So can you differentiate, I mean, which performed the best, and which the cluster orientation, which one is better to have it in a single row or have a properly clustered or anything? And you also did a earth shed building, so was that better?
I think you're speaking about the master plan, yeah? Yes?
Yeah.
About the final site plan, Shahab.
I'm talking about the clusters. So on the site plan, you have 2 different types of clusters. So the performance of those clusters.
So if you see,
Yeah,
Yeah,
go
go
on.
ahead. Go ahead.
No, go on.
If you see, definitely the clusters which are attached to each other kind of perform better, because then we have only north and south, two surfaces of the building that is actually kind of acting in heating up the space, because heating up directly by sun. But whereas you see the cluster which are independent villas, the four surfaces are kind of open. All the four sides of the building are kind of open, so that is more tend to have overheating issues. Yeah, but again, it was a suggestion from the SIHA that we have this third typology not connected to each other, because then it commercially works out for them, because then they get to sell that as an independent villa and get economical advantage on it. So that is why we had not attached those buildings, but yet achieved our numbers of having less than, that's 15 kWh meter square year.
The thing which is important in passive house is the heat loss form factor. So if you have a building which has all four facades exposed, it's really hard to achieve that low heat loss form factor. And as you can see, even in the terraced houses, which are very compact, which are all connected to each other, even the slightest change in the form changes that factor, and also the heating demand of the building. So when you are trying to incorporate passive house into your design, it does create some limits in the forms that you can use, and in the flexibility of your design. But it's something that you have to work with it. It's a give and take, really. And as Vishnu pointed out, both units managed to achieve our aim.
Great. Thank you. Thank you so much.
Any more questions? This is the last 2 minutes.
Anushka had asked about the earth shelter building, the community space. We actually haven't gone in detail to get that building simulated and understand the energy requirement of that building. So we can at present not in a situation to kind of talk about that. So we have selected only one unit, the row housing unit, to actually detail out all the simulations. Yeah.
Okay, I think there are no more questions. I feel this is the last time I'm asking. Are there any more questions? Okay, feel handing it over to Anushka now.
Yeah, so now this is like, because we are part of an action group, so our mission is for sustainability to be further embedded into our architecture education. And you guys have been part of Sheffield School of Architecture. So do you guys think that there's something needs to be changed to embed students and the architects to study more about sustainability and to bring more ideas into sustainable design? So something needs to be changed in our education pattern.
Shahab, you want to throw some light on that?
I thought this is a general question for everyone.
Okay.
Is it a question for us, or is it for the audience? I think you're muted, Anushka.
Yeah, you're muted.
For everyone who's been our alumni and current students, is there anything that needs to be changed or something has to be added to improve architecture education? No, I think everyone is happy. Great.
According to me, I feel people need to be more aware of what's going on right now, how the world is progressing, and as designers, what we need to do towards the same thing. I think that awareness is the key to things in today's world, is my opinion.
Great.
Sure, there are more other things.
Yeah, and I think that we need to have more education regarding what the implications of the materials, the designs, the detailing, and so on that we. I mean, architecture shouldn't just be about the art of the design. It should also be about the details and also the construction or the process of that. I think that's what's missing. Understanding it, even the slightest change in the material that you use can have a large amount of impact on the carbon footprint of any building. And also, as you saw, even in Passivhaus, the slightest changes in the design and the detailing of the building can change the energy demand and also the energy use of the building. I think that's what's missing. We're just thinking about the design and the art. That's important, but this is also important.
Great. I totally agree with that. That's great. So now we'll just wrap it up. And okay, so this has been a great lecture. And I'm sure this would normally be where we would, you guys would have a bit of an applause. So yeah. And so on behalf of the Climate Action Group and the audience, thank you very much for taking the time to speak with us today. And
I
thank
think
you everyone
Sahil
for
has a
attending.
response. So
Yeah.
sorry, I think Sahil has a response to our question here. So SAS could collaborate with some expert of construction in construction industry who has been in sustainability for a number of years, and I think it would be a good experience for us. That's a good idea. Thank you, Sahil. Oh, there's more coming. Could there be links to any other departments such as?
I'll just carry on with this. Could there be more links with other departments such as material science, engineering, and landscape to work with others to maximize design for sustainability? So this session is all about that because we have students from architecture, landscape, architects. So this is actually a platform where we are talking about it so that more students can get involved in sustainability. So thanks for the suggestion, Wing. Okay. And thank you everyone for attending today. And do follow us on social media. Get in touch if you would like to get involved in what we are doing. And keep an eye for our podcast. And also just a small reminder, we have a charrette tomorrow at 1 o'clock. Everyone is allowed to join. Everyone, please welcome. This is an amazing activity, a very interactive. So it would be great if you guys join. It's very much related to sustainable design. So it will be great to see you there. So all the best. Have a good day. Thank you.
And thank you so much once again. Yeah.
Great. Thank you.
You have been watching an open lecture hosted by Students for Climate Action from Sheffield School of Architecture. Catch up with us on our website at SSoAClimateAction.com to see what we're up to, for other content and resources, and for links to our social media channels. Thanks for tuning in.